It's recording. Alright. Of course. I throw that up there on my Xbox. Alright, take a seat. We gotta draw. So today's, come on. Today's drawing is going to be the last thing that we are drawing. It is the synthesis step of photosynthesis. Okay? So the synthesis step of photosynthesis. Yesterday when we were doing this, we generated three things, but one of them got sent out as a byproduct. What was that one that got sent out as a byproduct? Oxygen went out. So we generated three things. O2 went out. Okay, so the other two things that we made were what?
It was like the G3 something.
We made ATP and NADPH. Okay? So these are used for the next step. I'm going to put the Calvin cycle. Alright, because that's the step that we're about to do. Is called the Calvin cycle. It's also known as the light-independent reaction, meaning it doesn't need light. The first step has to have light. Okay? Because the whole goal is to break water down to make these two things right here. Break water down to make ATP and to make NADPH. And it's all, yeah.
I'm sorry, does the light have to be the sun?
No. Because in the past, I had a light bank right there, and we grew plants under it. There was no sun but that light bank there. So it's about wavelengths of light. So there are specific wavelengths of light that it likes. We're actually going to do a lab whenever they approve the software. One of the parts of the lab is going to be looking at a plant cell, and you can actually visually see chloroplast and all that. Another one is I was digging around in the back through the software, the probes that I have to see which ones I had. And I don't know why I never realized it. I have spectrophotometers. These are like $900 to $1,000 a piece. What they'll actually do, and this is what I was doing during the second period, is you take your fancy little molcajete, okay, mortar and pestle for my Blanco folks, and for M, yeah, okay, and you grind up leaves, and then you suspend it in an aqueous solution or a liquid solution, and you stick this in there, and what it does is it hits it with all the different wavelengths of light, and it gives you a reading that says, here's how much was absorbed at each wavelength of light. And it's going to tell you, okay, these wavelengths of light were reflected, these wavelengths of light were absorbed. And plants, or specifically green plants that have chlorophyll A, like very specific wavelengths of light. They tend to like the blue and the reds, as we were talking about. And you can visually see, is that what it actually agrees with this data, or am I just pulling your chain? And then you can try it with some other stuff. So this one is just because I was thinking about this first period and tried this during second period. I'm also going to try getting like blueberries, and I'm going to try buying flowering plants that have like red flowers and stuff like that, so we can make some and do this during the lab to try that. So that way we can see for the absorption. How did I get on that?
I talked about light.
Oh yeah, it's all about the wavelength of light. I was like, how did I get on that tangent? All right, so this whole thing right here, this whole step is called the Calvin cycle.
Named after?
Named after a guy named Melvin Calvin, who was a professor at UC Berkeley. He was my eye doctor's botany professor.
What?
Said he was the worst teacher he ever had. He said the guy was clearly there just to do research because he was one of the most brilliant people on earth, and they're unfortunately required to also teach. And so he said the guy would come in, he would go to his chalkboard, and he would go to the chalkboard and just write for an hour straight. And he said he would never want to turn his back to the class. He said that was the hardest class he ever took in college, was that class. He said his very first test he got a 15% on it. Yeah. All right, so we've got this whole step called the Calvin cycle, meaning the things in this are going to cycle through. So I'm going to start with something. I'm going to start with a molecule, and I've got 6 of them. I've got 6. Pen's trash. Ooh. Okay. I've got 6 of this molecule called Ruby P. 6 of this molecule called Ruby P. underneath this in green, I'm going to write little dots. So it's going to be lines and dots. That's going to show you how many carbons are in this molecule. So this one right here is 1, 2, 3, 4, 5. So I have this just so you can visually see how many carbons are in this molecule, because this whole thing is about carbons flowing in and carbons flowing out. So I've got 6 of these 5 carbon molecules for a total of how many carbons? 6 times 5. 30. Great, thanks. All right. Then what's going to happen is this thing right here, something's going to come in. Okay? So the thing that's going to come in is I'm going to have 6 CO2 molecules come in. 6 CO2 molecules come in.
That was a moment.
She was just sitting there with the most weird, awkward, happy smile, like,
We just discovered that we're going to wear jean on jean on jean
Oh.
for homecoming.
oh, the Canadian tuxedo.
Yes.
Okay.
And she was happy about it.
And 'cause she's smiling in this class, and that's very irregular. All right, so I took 30 of these things. I have 30 carbons right here. I have 6 of these 5 carbon Ruby Ps, and I incorporate 6 CO2 molecules. How many total carbons do I have now? 6 plus 30, 36.
36.
Okay? But what it's going to do, it's going to rearrange them into these different molecules now. All right? It's going to form 12. 12 of these molecules called 3-PGA. 12 of these molecules called 3-PGA. Each one of these is 3 carbons. This is more stable. So I've got 12 of these. I have 36 carbons. 12 times 3, 36. Okay? And I've got a name for this step. This step right here, I'm going to write it in a different color. Okay? This step right here is called fixation. Alright? And so now I've got this thing. I've got 12 of these 3 carbon molecules, but I'm going to start adding some stuff to it. Do you remember the 2 things we generated during the light-dependent reaction?
ATP.
ATP and NADPH. So right here, okay, this is going to come down, and something's going to come in right here. Okay? 12 ATP are going to come in, and 12 ADP are going to come off, meaning it dropped off a phosphate. Meaning it has to take energy in. Meaning is it endergonic or exergonic? It's endergonic. It's endergonic. Because remember, this right here, am I trying to build stuff or break stuff down? I'm trying to build stuff. I'm trying to make glucose. And if I want to build something, it's going to require energy. So energy must come in. But the other thing that I had that came in is right here, 12 NADPH come in, and 12 NADP plus come off. Holy moly! And this produces something. It produces a different molecule, okay? But this step right here has a name. This 3-PGA molecule gained electrons. This thing came in here and dropped them off. It was phosphorylated because ATP came in here and dropped off phosphate. So it's phosphorylated. But then it also gained electrons. And we have a term for if something gains electrons, it is what?
More.
Remember oil rig.
Wait, oxidation is
Losing.
reduction in
So if it gained electrons, it was what, Peyton? You just said it. It was an R word. Reduction. So this step right here is called reduction. So 3-PGA gets reduced. NADPH comes in and reduces 3-PGA. Okay? And it forms a different molecule. We have 12 of these molecules called 12G3P. G3P is very, 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 very similar to pyruvate. Remember where pyruvate was found?
3 carbon.
No, that was
Pyruvate was that 3-carbon molecule that I saw where?
in the mitochondria.
In the so it wasn't in the mitochondria. It was at the. Well, it did go into the mitochondria, but it was at the end of glycolysis. Okay.
I'm awful.
So I've got 12 of these for a total of how many carbons? 36. Okay. I am going to lose 2 of them. Two G3Ps get kicked off. 2 G3Ps get kicked off. Now I've got 2 3-carbon molecules that are very similar to pyruvate. What do you think happens if I combine them?
They return as UVP.
Not if I combine 2 3-carbon molecules. Think about the pyruvates. Where did those 2 pyruvates come from?
Glucolysis.
Okay, they came at the end of glycolysis, but what happened in glycolysis? What did I use to make those 2 3-carbon pyruvates?
To activate the
ATP doesn't have or it doesn't have the carbons for it.
I have a question.
Na.
Nope. Those 2 pyruvates. The whole process of glycolysis is about doing what? What big step? Break the word down. Glucose. If I combine these 2 G3Ps together, I get glucose. I kick off 2 3-carbon molecules and I combine them together and I get glucose. Okay?
How'd you open 12 2?
I kicked off 2. So it says we're a chain of 12 and it says, hey, 2 of y'all get off here. And now we've got how many? 10. Okay? And now I kicked off 2, meaning I have 10 G3Ps. Okay? But, I'm going to draw 3 dots here. How many carbons do I have here total now? 30. And right here I had 30. What's going to happen is it wants to go towards this molecule again. All right? And in order to do that, it wants to rearrange it. It's going to cost 6 ATP. So 6 ATP come in and 6 ADP come off. And this step right here is called regeneration. Regeneration. And that's the Calvin cycle. Siriana.
Okay, so here you turn ATP to ADP. So how do you turn ATP to ADP again? If like you didn't have that.
I have more ATP.
So even though ATP is turning to ADP, there's still ATP.
I still have ATP from the, what's it called? The light-dependent reaction. I have more ATP left over from the light-dependent reaction. Yeah. Okay. So this is the step. So remember, the first step, light-dependent reaction, is the photo part of photosynthesis because I have to use sunlight. Did I make anything in that step? Like anything big?
No.
No. I use I used sunlight to break it down to produce these 2 intermediate things. But then I turned around and used those for this step, the light independent reaction. This step can happen whether light is on or light is off. Okay? It's called the Calvin cycle. All right? And what happens here, this is the synthesis step. Because what's my big thing that I'm synthesizing? Glucose. That's what I want to make. That's my whole goal, is to synthesize glucose. So, theoretically, I could just do this stuff on its own if I had an endless supply of this, but I don't. And so I have to have sunlight to break apart water to make ATP and NADPH, which are used to drive this step. Because I really don't care about ATP and NADPH for the overall thing of it. What I care about is making glucose, but I can't make glucose without that. Graki.
Can you go over again the RUBP
Yep.
and how there's 30?
Yep. So, just to walk you through all this, here's where we kind of start from. We start from 6 of these 5-carbon molecules. Okay, 6 5-carbon molecules for a total of 30 carbons, if you are to look at the sum total. Okay. CO2 comes in. Okay. So now I have 6 of them that come in. So I had 30. Now I have 36 total carbons. It's going to restructure it. It's going to say, hey, I don't like these 6 carbon molecules. I'm going to rearrange it, and I'm going to form 12 of these 3 carbon molecules called PGA. So I've got 12 of them. And then it says, all right, I need to decorate these things. I want to reduce them. So I'm going to have ATP come in. It's going to phosphorylate it. So it's going to give it a phosphate. It's going to energize it. And I'm going to have NADPH come in, give it some electrons and some hydrogens. All right. And what that's going to do is going to turn it into G3P. I've got 12 of these G3Ps. Each of these is 3. So I've got 12 of these 3 carbons for a total of 36. I've got 12 of them, and it says, hey, 2 of them are going to split off. All right. And that leaves me with 10. Those 2 that split off eventually will combine. It's basically like 2 pyruvates doing glycolysis backwards, and now they form a glucose molecule. That was my big goal, was to make that. I'm left with 10 of these 3 carbon molecules. Can't really do anything with those G3Ps. So what I've got to do is I've got to restructure them to form that 5 carbon molecule again. So it's going to break it all apart, kind of like a set of Legos. Let's say you got 10 things of Legos that were small, and you're like, I want to make bigger things. So you have to break it all apart to make this bigger thing, but it's going to require a little bit of energy to do that. And now you're back at step 1. So now you can do this whole process again, and then whole process again to make glucose over and over and over again, so long as you have enough ATP and NADPH, and you're bringing in carbon dioxide. So this is why plants need their carbon dioxide, because they can't do this without carbon dioxide coming in. Okay? I'm going to erase the stuff that if you, like what you should be able to fill in. Like if I were to give you a blank one of these, you should be able to fill in. I'm going to erase the stuff and I'm going to put lines where you should be able to fill in. Okay? So if you were to draw a template that you would put behind a sheet protector, that's basically what I'm making you right
Can we
now.
draw the template in the back?
Huh?
Can we draw a template on the back of the paper?
Yeah, that's why I gave it to you. I should have taken a picture of that. Because I won't be here 5th period, and so.
Just sick clean.
Let's make this template.
I guess I'll draw this. Are you really?
Someone with an iPhone, you want to take a picture of this so you can airdrop it to me afterwards?
She got it.
Let me erase this. Thank you.
A big piece.
Which one's your airdrop?
I won't be able to accept it right now because I'm filming this for 5th period. Yeah, it says Anthony's iPhone.
On our class.
If you want me to.
I'm feeling filling it in every time I do this.
I don't like
For
this.
real. For real. I get you. Yeah.
Ellenberger was
Oh,
amazing.
that's what we're supposed to do.
The phone rang, and so he grabbed the phone and they went,
Also,
Hello?
just like, is this like a practice or what?
Who did?
Ellenberger.
We're all tired. We're all trying to get back in the swing of things.
I'm trying to go back to sleep.
Yes.
Oh, I can't read it off.
Well, line. Oh, that's something. Yes.
But it's not
so confusing. And I understand.
When what?
I feel smart when things look confusing, but it's something I understand. Like if somebody were to see the word like
That's how I felt when, like, cellular respiration, when all the drawings, when I'd combine all three of them on like an 11 by 17 paper of glycolysis, citric acid cycle, and electron transport chain, and look at it, I'm like, I am the smartest man alive.
because it looks so complex.
It does.
Yeah, I forgot everything.
That's good that you get this. When I was in college, this was the thing I struggled with the most out of all of the topics in bio was photosynthesis. Was the one I struggled with the most.
Why? Was it the teacher?
I don't know. I think I just had something against it, and so I didn't. It's
You're-
bad to say I didn't want to learn it. I think I just kind of shut it out and always told myself I wasn't good at it and didn't understand it. When this is no more complicated. This is actually probably easier than cellular respiration.
Yeah.
All right, you guys ready? So let's label these steps first. This step right here is called fixation.
Wait, you should like pick sticks and have people fill in.
I'm going to. Oh, pull sticks?
Or like
No, I would, but there's no point because you all have a key right in front of you. So I know everyone 100% has the right answer.
I won't look.
Okay? So we're going to start off with this molecule. Okay? Right here, I've got how many of them?
5, 6.
6. I've got 6 of these molecules called RuBP. R-U-B-P. And it's a 5-carbon molecule. So 1, 2, 3, 4, 5. Okay? Something comes in and gets added to it or fixed to it. 6 of these CO2 molecules. Okay? And it gets restructured to form what?
3 PU.
12,
Oh.
3 PGAs.
There you go.
Okay? And that's a 3-carbon molecule. Okay?
Oh.
And now I've got to decorate it basically. I got to make it all fancy. And something's got to come in. All right, that first thing that comes in is 12 ATP and 12 ADP come off. And then 12 NADPH come in and 12 NADP plus come off. And this whole step right here is called reduction.
Where does the hydrogen go?
It gets combined to this. So it adds to this.
Oh, so
I'm abbreviating these. This is called 3-phosphoglyceraldehyde because if you look at it on a molecular level, there are oxygens, there are hydrogens, stuff like that attached to this. That 3 is just telling you the phosphate comes off of the 3rd carbon.
so did the NAD plus go back to like the light reaction?
Yes. Very good. Very, very good.
Yeah.
Siri just asked a very, very, very good question. Okay? She asked what happens to the NADP plus? It gets recycled in the light-dependent reaction. So that NADP plus is then going to go back to the light-dependent reaction. Because that NADP plus was in the stroma. All this happens in the stroma. Okay? And so we've got reduction, all right, because 3-PGA is going to have hydrogens come get added to it with electrons, so it's going to reduction. And it forms 12 of these molecules called G3P. 2 of them get kicked off. So 2 G3Ps get kicked off. Okay? And this G3P was a 3-carbon molecule. Okay? And 2 of these things together combine to form a glucose. Okay? If I lost 2 of them, I'm left with 10. For a total of 30 carbons. All right, the G3P, remember, are 3 carbons. And so now I'm going to undergo this process called regeneration. And in order to do this, to take this, break it down, and build this up, I've got to have 6 ATP come in and 6 ADP come off. Okay?
What's the ADP do?
What's what?
What's the ADP do after?
It's going to go back to the light-dependent reaction where it's going to get recycled when I phosphorylate ADP during ATP synthase. Good question. All right, so This is all of it. You want to take another picture of this now that it's filmed in?
Yes.
Por favor.
Before and after.
Biggest glow up ever.
True. The process is pretty sweet. Literally.
And then both of the sugar.
Haha, comedy.
Comedy, that doesn't make sense. All right.
It does if you get it.
That's
All right,
smarter.
we got to do a little bit of notes to kind of go over photosynthesis stuff. A little bit. Because we've got to start talking about chemicals and chlorophylls and pigments. Why do leaves start out green and then all of a sudden go to red and yellow and all this stuff? Nobody knows. It's witchcraft and wizardry. It's Hogwarts. No, we know.
I thought I was still missing.
This is still part of Unit 4. These notes are still part of Unit 4. It's just photosynthesis. Okay? So this is photosynthesis of Unit 4.
So the rest of it is fine.
They're all back here if you want them. I'll give them to you tomorrow.
Well, stuff to remember.
You'll need it before we do this lab, but that's all contingent on when they approve my software.
Oh my gosh.
But still, like, cooked.
Huh? I don't have it on Pear Deck right now, I'm sorry.
Are you okay?
Just don't go too fast.
Don't write too slow.
I need to know. I just know what I'm writing. So should I title this photosynthesis?
Yep. What does photo mean?
Light.
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 Photo means light. And what does synthesis mean?
To create.
To make or to create. Alright? So, I'm creating stuff from light. I'm making glucose from light. We have organisms called autotrophs. Organisms called autotrophs. I'm happy for you. I love lamp.
What happened?
It's pretty chill. Took my dogs to Utah, southern Utah to go hiking. We had fun. It was snowing in the desert, so we were like hiking on sand dunes that were covered in snow. Huh? My parents still buy me stuff again, and I insist very much not to. They bought me some more tool stuff and a bed cover for my truck. So that's pretty cool. Adult porn.
I know, when you're older, you get useful stuff.
Like we're now at my age, I want socks. Socks and underwear as an adult is like gold.
I was like, okay, so I have like, and then they
You know what
talk
was
about
really
this,
good?
and they have socks.
Mm-hmm.
It was like,
I do that.
Wait. Hey, Drudge.
I get mine from like Costco. Big merino wool socks they have at Costco right now.
Drudge. Are you gonna keep this recording or?
Yeah.
Alright.
So don't say anything stupid.
Bet.
oh, you're
I already said
Yeah.
something stupid.
It's over there.
You're right. Sorry.
You really did.
I don't think you can hear.
But it doesn't matter, Brandon. Alright.
This is Dress. I told my dad about like how you travel a lot, and the first question he asked was, "Does he have kids?" I'm like,
That's a very big question.
I was
yeah.
like, "Dude, does his dogs count?"
That's what my Estes and I were talking about because he was talking about before he like when him and his wife first got married before they had kids he traveled and stuff.
See, kids, they like.
Ruin your
Are
life.
expensive.
This is what my parents say to travel first.
I mean,
That's what my biggest recommendation is: you travel first and then have kids. Enjoy your life while you can and then have kids.
Or just enjoy your life
Get
forever.
cats. No, they're
Like,
not.
I'm saying if you want to have kids
Oh, I
and
mean,
live your life a little. Like my little sister, she wants to have kids and stuff, but they're living their life right now before they can.
like, if you have secrets, kind of like.
She's on a cruise to like Jamaica and Grand Cayman right now.
Oh my gosh. I was scared going to cruise in like areas.
My mom did college and 4 kids.
And then there's sharks.
okay, chill out.
Sharks don't care about you.
Tell that to Steven Spielberg.
Yes.
Dude, bro, you're freaking like.
You're what?
kinda, like conspiracy theories over here.
All right, you ready? So auto. Anyone know what auto means?
Self.
Auto means self. And troph means energy. Okay? So this means it's going to get energy from itself. Is that what we do?
No.
No, we have
Nah,
to.
boo boo.
We have to.
We've got to eat. Some of us more than others.
Hey.
I didn't even
I saw
look at you.
laugh at me.
I didn't even look at you.
Get yourself over there.
Okay.
I saw you look over here and then you went doop doop. Don't lie to me.
Okay. We get our energy from other things, but autotrophs make their own energy. Then there are other things called chemosynthesis. All right. They capture chemical energy. A lot of times chemosynthesis happens in like bacteria or things that are like extremophiles and stuff like that, where they can get them from like hydrogen sulfide that comes from vents way down deep in the ocean, where they have like, it's almost like a little volcano or a geothermal vent where it spits out hydrogen sulfide. They can get energy from that. All right, so that's chemosynthesis, it's using chemicals. Our plants, do you think they get their energy from chemicals, or where do they get their energy from? They get it from the sun. Okay, so they make their own energy. Do we make our own energy?
No.
No, we get it from other things. Do we know a word that means different or other?
Hetero.
Hetero.
Yes. Blood.
Yes. You go, queen.
She's like.
How do they like wash the blood?
They'll lick themselves
I'm just gonna wear it. I'm wearing it.
when they rub around. They'll also have other ones who will lick the other ones.
So doing showers are overrated.
I know, that's why when I'm dirty, I just lick myself.
I didn't even know that.
That's what you do?
So I didn't even know that.
Oh, they said, how did you know that? That's what Grace was doing in the back of the bus yesterday. I just heard this like licking noise, and then all of a sudden I heard,
You're the one hissing at me every 5 seconds.
as she coughed up her hairball.
I have no hair to cough up.
It's okay. I get it, because I got in a biting match with my dog the other day, because he was biting me, so I decided to bite him back, and then I ended up with a mouthful of hair. It's kind of fun.
How did you bite each other at the
No.
same time?
It's huge. How did what?
How did you bite each other at the same time?
Because I know him and my sister dog wrestle all the time, and they bite each other on the neck. Like that, there's a lot of loose skin on the neck, and so that's why he'll run at full speed, grab her by the neck, and then like body slam her down. She's a husky, and so that's how I'll bite him, and then I'll like grab him by him and pull him by his neck.
I need a video of this.
Well, the kittens have a little scruff too, but they lose it after a while.
He's got thick hair. He's like a golden retriever, Great Pyrenees mix. So he's got thick hair, and yeah, there's a lot of skin on their neck. That's how they wrestle all the time. All right, heterotrophs. What are some things you eat?
Gummy worm.
Okay, McDonald's, gummy worms, all that. That has a lot of carb. McDonald's has a lot of carb. Burritos. All right, but
My
okay,
diet
but
is bread.
tortillas.
Great.
Tienes carbohidratos. Okay. Carbohydrates.
No,
Carbohydrates.
what about hot Cheetos?
Carbohydrates.
Cheese.
Cheese.
Potatoes.
Okay, but cheese comes from where?
Cows.
Cows, or goats, or buffalo, or anything. Where do they get that? What do they eat?
The grass.
Carbohydrates.
Ah!
Okay.
What about like I don't know, like a single strawberry?
Like.
Carbohydrates. It all comes from
A
plants.
taco.
Let's go back to
There's
carbohydrates.
cilantro in tacos.
McDonald's.
Cilantro's a
What about
plant,
meat?
Okay.
Good.
What about what?
Like a steak.
Wait, what about?
It comes from a cow, but that cow eats grass.
I'm just gonna feed cows other cows.
I have a question. What
Yeah.
about that fish from Finding Nemo that has little light because it lives so under the water and doesn't need sunlight?
So they probably eat like plankton or something very, very, I don't know if plankton can go that deep. They probably eat something very, very small, which eats something else, which eats something else, which feasted on that. Yes.
What about that like lab grown meat?
That, I don't know that. You got me there.
Like McDonald's.
Go ahead.
Which leads me into this whole unit is unit 4, it's energy. We started off with enzymes, then we went to cellular respiration, now we're on photosynthesis, and after photosynthesis, we're going to close it off with food webs. Because food web's all about primary consumers, secondary consumers, producers, all that stuff, because it's the flow of energy within a system. So yes, you might be grubbing on a fat T-bone or a fat ribeye and thinking like, I ain't eating no carbs. Nothing
I
about
hate potatoes.
nothing about this was an autotroph, but that ended up having to eat grass, which is an autotroph.
That's awful.
Okay, so we get our carbon compounds from other things, all right? And so we're heterotrophs, but the one we're concerned with today is plants. They're photoautotrophs.
Wait, so plants are autotrophs and photons?
Yep. They're Yes. Not all autotrophs are photoautotrophs, but all photoautotrophs are autotrophs. So not all things that make their own energy make it from the sun.
What else?
Chemosynthesis. That's what I was talking, like those bacteria that live very deep in the ocean by hydrothermal vents. They make it from chemicals in the ocean.
Yeah, we also got things that live in ice. I don't know.
No.
Oh, my nicest handwriting.
I thought you said my ISIS handwriting.
Are you from ICE? Jesus Christ. I'm just kidding.
Are you singing? Oh, they were singing Amazing Grace.
Excuse me, I'm right here.
It's okay, don't worry. I'm not trying to hurt you.
Hey, Johnson.
He doesn't want to talk to you.
Damn, disrespect. Dr. Disrespect, bro, where he at? Subscribe to PewDiePie.
I know. It's because they sent it down.
Hey, Brandon, you know I have control over the phone, right? So I can just say whatever I want, anything controversial.
Yeah, I know you had
It's pretty good, man. It's good to be empowered. Because, you know, white power, alright? What? Yeah, they do.
They never use it to eat.
Yes, they do. They grind it up and decide. Which one do you think is nice?
Don't they like regurgitate their food? They have like trays on it or something like that?
No, they don't do that. If that was the case, what would you say? They would just die out.
Alright, so photoautotrophs. Plants are photoautotrophs, meaning they use the energy of sunlight to make organic molecules from water and carbon dioxide. Can you think of a process that they might do where they use sunlight, water, and carbon dioxide to do this process, to do a process? Have you heard of any process like that? Photosynthesis. Okay? It occurs in the chloroplast. Like I said, when we do our spectrophotometer lab, the other half of that day is going to be a microscope lab looking at plant cells to see if you can see the chloroplast.
So that's basically what we're trying to find, right?
Yep,
The green
to
dot.
see if you can find it on your own. Did you enjoy not having school for a day
Yeah, I did.
and getting to eat lots of food?
Sounds like fun.
Several people who went yesterday had never had Chick-fil-A.
Yeah, that includes me.
I think it's good. A couple people who said it was overhyped. I love it.
But I was like,
Punch you in your face.
Florida.
Alright, chloroplast. Dude, hold on. You what? Okay. Photosynthesis takes place in plants. There are some organisms that do it, very few, like sea snails that have digested algae and they've found ways to incorporate chloroplasts into themselves. But plants do photosynthesis to make glucose. For some reason, there's a very, very big misconception that plants do photosynthesis and we do cellular respiration, and that's just how it is. Plants also do cellular respiration. Well, let me repeat myself. Plants also do cellular respiration. Plants do both photosynthesis and cellular respiration. For some reason, people think plants are over here like, I'm going to do photosynthesis and then sacrifice my glucose to the gods. And they think that that's why plants are grown is purely for us. Like, their whole purpose is to produce carbohydrates for us to consume. No. Plants produce carbohydrates so when they need energy, which they need it a lot, that they can break that down through the process of cellular respiration. Because plant doesn't have a way to go to Carl's Jr. A plant can't just bust a mission to in and out. All right? But we can. So we don't have to do photosynthesis. You might find Grace laying out in the grass during lunch trying to do photosynthesis. That's just Grace. But we cannot do photosynthesis because we are heterotrophs. We eat other stuff. Plants must do autotrophs. They do photosynthesis so they can then turn around and break that down during cellular respiration. Good game, America.